Hi guys, this is Sakshi and I welcome you all to my EduTech platform, Way to Learn. So we are going to solve PYQs from differential equations in this video, and we will be solving around 3 problems today, and there are around 11 or 12 problems from differential equations from June 11 to December 2019, and they are of CSIR-NET Physical Sciences. So before we start the video, that is our question session, if you are a new viewer, please subscribe my channel, and if you guys like my videos, please like my channel and also share my videos to your friends and help them out if they have got stuck in some problems. Okay, so let us start our first question, which is from December 2011, and here we have x1 of t and x2 of t to be the two linearly independent solution of the differential equation given. So we know that on solving a differential equation, second order differential equation, we will get two solutions. So those two solutions are linearly independent as given in the question, and they are denoted as x1 of t and x2 of t. And then they have given w of t is equal to x1 of t dx2 by dt minus x2 of t dx1 by dt. So now if you see this given question, I can write this w of t is equal to x1 x2 prime minus x2 x1 prime. So this represents Wronskian of a function, right? So this is the Wronskian given. This is x1 prime. So this is the Wronskian. And if you have seen my Wronskian video, then you will remember the equation which relates w of t with some other value of like w of x. Because in this question, it is given that if w of 0 is equal to 1, then w of 1 is given by. So we'll have to find w of 1, whereas we have w of 0. So we have to use the relation where w of x is equal to 1. We need to find w of x is equal to 1, which is equal to w of x is equal to 0 e power x0 to x1, x0 to x1, p of x dx. So what is this p of x? Now we have this differential equation over here, and p of x is this term, is coefficient of therefore p of x will be 2. Now we have to directly substitute in this formula given, which is w of x is equal to 1, and what is w of 0 is equal to 1. So w of 0 is 1 into e power x0 is 1 and x0 to xn, this is xn, sorry, 0 to 1. I am going to consider this as 0 to 1 because I'll have to find for x0 and x1, right? That is it is from x0 to x1 over here. So p of x is 2 dx. There is a small change, there is a negative sign over here. 1 by e squared. So this is option D. Very simple question. You just have to remember this relation. Let us see the second question. So here it is from June 2012. Y of x be continuous real function in the range 0 to 2 pi, satisfying inhomogeneous differential equation. So they have already given that it is inhomogeneous, that is our RHS will not be equal to 0. And the value of dy by dx at point x is equal to pi by 2. We have to find the value of dy by dx at point x is equal to pi by 2. So we'll have to check which option suits the answer. So first, basically, we are going to solve this question and find dy by dx at point x is equal to pi by 2. So for that, we have our equation, which is now this equation does not satisfy any kind of equation that we know, right? Uh, this is not of dy by d square by dx p of x dy by dx is equal to q of x, right? And if even you bring this sin x to the denominator, if you divide sin x, then you'll have tan term, then 1 by sin x delta of x minus pi by 2, which will be like a bigger problem to solve, a lengthier one. So here we will use d by dx sin x dy by dx is equal to delta of x minus pi by 2. So if you see here, I'm just simplifying this LHS. So if I differentiate by UV method, I'm going to get the same as in the question, right? If I keep u constant, that is sin x, and differentiate v, which is dy by dx, uv prime will be d square y by dx plus u prime u prime v. So u prime will be cos x and dy by dx. So that is our LHS that is given in the question. So I am writing as this. Now this becomes a first order differential equation. Now first order differential equation is easy to solve. So I'm just going to integrate the entire thing. So on integrating, I'll get okay. Now this is what I have got after integrating. That is, I haven't integrated actually. This is the equation now. Now we know that we'll have to find what is dy by dx at x is equal to pi by 2. Okay, so when x is equal to pi by 2, when I substitute over here, I'll get sine pi by 2 dy by dx is equal to delta of pi by 2 minus pi by 2. So, we know that for a delta function, if you do not know, please just turn on your mathematical Dirac delta function and please see that the properties of Dirac delta function. See, here when x is equal to pi by 2, the function will be 1. It will spike up to infinity. And when x will not be equal to pi by 2, the function will become 0. Okay, so you'll have to remember this. So now when x is equal to pi by 2, our function will be, this function will get 1. So dy by dx will become 1. Okay, now we have to choose an option which satisfy this condition. Okay, so the option says that the value of dy by dx at point x is equal to pi by 2 is continuous. So we'll have to find if it is continuous or is it discontinuous. We know that the value of dy by dx is 1. So now the one, the only option that has 1 is option D. Okay, but we'll have to find if it is continuous or discontinuous to differentiate with respect to option A and option D. So we'll find how is this dy by dx continuous or not. We know that at x is equal to pi by 2, our Dirac delta function will be 1. So we get dy by dx is equal to 1. When x is not equal to pi by 2. That is, on other values of x, for all other values of x, our Dirac delta function will be 0. Therefore, dy by dx will be 0. Okay, so our function, that is dy by dx, is not continuous. It is discontinuous. Continuous is basically like at x is equal to pi, if it is 1, and at x is equal to pi by 2, this is 1. We know. So the function is continuous. Okay, but here the function is not continuous because at x is equal to, like, at all other points our function will be 0. So at all other points our function is continuous, but only at x is equal to pi by 2 it spikes up to 1. So at that point alone it is discontinuous. So we'll have to say that it has a discontinuity of 1. Now let us see the third question, which is from CSIR December 2011. A function f of x obeys the differential equation given and satisfies the condition. We also have the condition, and f of x tends to 0 as x tends to infinity. So this is also the other condition given, and we have to find the value of f of x. So now basically we'll have to solve this because it is an homogeneous differential equation. So we'll have to solve this homogeneous differential equation. You can write this differential equation. We can write this differential equation as m squared minus 3 minus 4i equal to 0. Okay, I am writing the auxiliary equation over here. If you do not remember what is auxiliary equation and how to find the solution of a homogeneous or non-homogeneous differential equation, please kindly check my differential equation video from mathematical physics. I'll add that to the description box, so please check that. It will be easy for you, and you can also have a revision on that. Okay, so now we'll find the roots over here, which is which will be m square is equal to 3 minus 4i. So m will basically be root over 3 minus 4i, plus or minus root over 3 minus 4i. So now, in order to get the roots which will be useful for us, I'm going to just simplify this roots over here. You can also think and try to remove the square root, and how do we like this thing can apply something in order to remove the root from the square root from the given answer. Okay, so now I'm going to write this as 4 minus 1. I'm going to write 3 as 4 minus 1. Okay, minus 4i is already here, so I'm just writing this, and now this is equal to 2 minus I the whole square, which is 4 plus I square minus 4ab, that is 2ab, 2 into 2 into 4i. So my plus I square will be minus 1. 4 minus 1. Okay, so I can write this as 2 minus I the whole square. Now the root and the square root will get cancelled out. So my actual root will be plus or minus 2 minus I. Okay, so these are complex roots. So my solution will be, okay, in terms of f of x. We'll have to write in terms of f of x. My solution will be f of x is equal to a e power 2 minus I into x plus b e power minus 2 minus I into x. So we know that according to the question f of 0 is equal to 1. That is at x is equal to 0, function f of 0 will be 1. Okay, so e power 0 will be 1. So 1 is equal to a plus b. Now, according to the other condition, the function will tend to 0 as x tends to infinity. So I can just directly write it as 0, and I'll get e power infinity plus b e power minus infinity. You have to remember that e power infinity is infinity and e power minus infinity is 0. Okay, so this term will vanish and you'll have, and this term will be a into infinity. Uh, can you say that any term can exist when it is multiplied by infinity? So a into infinity will be some higher value, right? So we should not have that a into infinity term over here. So, but I can say that this infinity term is not over here. I can just neglect this infinity because x is just tending to infinity. Okay, so now when x is just tending to infinity, I'll have a e power infinity, and that e power infinity will give me a into infinity. So infinity is nothing but a very very great larger value. Okay, which we cannot find. So I can say that okay, there is some a value which is multiplied by some very large value. Okay. Now according to the given equation, a into infinity will be some higher value. So and which is equal to 0. So from this equation, I can say that a is equal to 0, and from this first equation, when I substitute a is equal to 0, I'll get b is equal to 1. Okay. So now we'll have to find that f of pi is what? Okay, now you can write the solution of f of x. Will not have the first solution. This will go to 0 because a is equal to 0. We'll have b is equal to 1, so we can write that b is equal to 1. So we'll have the solution to be e power minus 2 minus I into x. So now at x is equal to pi, f of pi will be e power minus 2 minus I into pi. Okay, I can write this e power minus 2 pi dot e power I pi. Okay, so e power I pi is nothing but cos pi plus I sin pi, which is equal to minus 1. So f of pi will be equal to minus e power minus 2 pi. So this is a very easy question. So I hope you all got this question how to do the steps. These are just simple steps. You'll have the solution. You'll have to substitute the uh, given condition and find the uh, constants a and b, and then find what is given, what is asked in the question. Okay, so that's all for today. Thank you. Like my videos, share my videos, and subscribe my channel. And do not forget to hit the bell. So for further notifications, you'll have to hit the bell, and you'll have three options like all, personalized, and something else. So you'll have to press all to get my notification. So see you tomorrow. Ta-da!